Hello and welcome to another video, this time on compound interest practice and problems, right? So in the previous video, we already came to this formula or this form, and by now we should already know what A, P, R and N means. A is the amount, P is the principal, R is the rate and N is the number of time period. Now we are at this juncture, we are assuming that you already are very familiar with what principal means, what amount means, what do we mean by rate of interest and what do we mean by time period. So here we are going to straight away start applying this formula and start saying, okay, what is the trouble area, what can I learn from this, right? So let's start with a very easy example. Let's say the principal is 500 rupees, right? And the rate is 10%, and we're talking about a time period of 2 years, right? And the question is, what would be the amount after 2 years? So in the language form, the question would say the principal, the money invested in an account at 500, compounded annually at the rate of 10% for 2 years, what would be the amount, right? Straight away, plug in the formula, I want the amount, so amount is equal to P, which is 500 into 1 plus 10 by 100 and raised to 2, right? This 1 plus 10 by 100 obviously works out as 110 by 100, right, raised to 2. Now if I cancel out the zeros, I get this 11 by 10. Now if you have gone through percentage basics and ratio and variation, you should be very familiar with this idea of multiplying factor. That is the second thing we learned in the previous video, that how can we connect this formula to whatever we have learned earlier in percentages, because this is nothing but a percentage application. So my question now becomes 500 11 by 10 square, right? 11 square should be fairly easy, so this becomes 500 into 121 by 100, right? And you can work out this value. But if you are familiar with the meaning of multiplying factors and what does this 121 by 100 means, that means 500 has been increased by 21%, right? So what I could have also done is, I could have done 500 plus 21% of 500, because maybe this calculation would be easier for you, right? So this is the very most basic example, we're just plugging in the values and getting to the answer, right? Another way of thinking, just to get familiar with the idea, would be to start with 500. After 1 year, what would happen? This would become 550, right? And after 1 year, what would happen? This 550 would be increased by 10%. 550 is 10% is 55, so add 55 to this, you get 605. So you could have, at least in this case, worked out your answer just by using the numbers, because the percentage was pretty easy, right? Let's try one more example. Okay, so in this example, the amount is given, the rate of interest is given, and the time period is given. So what is missing? We have to figure out the principal, right? So again, start with using the formula. I know A is equal to P into 1 plus R by 100 raised to N, right? I know the amount, so plug that value here, 43,560 is equal to P into 1 plus R by 100. R is 10%, you should be faster by now. This is 110 by 100 square. This 0 gets cancelled. So 43,560 is equal to P into 121 by 100. So all I have to do to figure out the value of P is move this 121 by 100 to this side, it will become 100 by 121 to 100. Calculate this and you will get your answer. Again, you might be getting stuck here in this particular calculation, but then remember, the problem becomes about calculation and we can cover it in a separate discussion. But as far as the compound interest is concerned, there is no problem in the concept, right? So, and again, notice the use of multiplying factors, because you would have straight away, what you would have done is, you would have forgotten the formula and remembered that the principal is growing by 10%. So that means first year it would be 11 by 10, and second year again 11 by 10 is equal to 43,560, right? So once again, go through the percentages chapter in case you haven't done that, and you will see this is a very familiar idea. We have done this a number of times, right? So again, the very basic formula, And we've been saying this over and over again, whenever you learn the formula, learn it from all directions. In the previous question, principal, rate and time were given, amount was not given. In this case, amount was given and principal was not given. So what you can also do is that when you learn a concept, you can try it by yourself. Just try removing one value at a time so that you thoroughly learn the formula, right? Obviously, the next question is going to be, the rate is going to be missing, right? So let's try that example. Okay, so as expected in this example, we have the principal as 1 lakh, we have the final amount as 1,10,250, and we have the time period as 2 years, and the question is about the rate of interest, right? So this is one trouble area that we encounter in compound interest, that is finding the square root. And what do we mean by that? So use the formula. I know 1,10,250 is equal to 100,000 into 1 plus r by 100 raised to 2, right? So I have to find the value of r, right? That means move this 1 lakh this side, so I'll get 1,10,250 divided by 1 lakh is equal to 1 plus r by 100 raised to 2. I have to find the value of r. That means I should eliminate this power here. So I'll take a square root of both the sides. So this is what I'll get. So I can start working out the numbers, but I already see this process, finding the square root, is not a very familiar tool for me. We don't often find square root of numbers, and the process itself is a little cumbersome. It will take some time, right? And that is a fundamental trouble area in compound interest, that how do you deal with square root, right? And the square root still might have been easy in guessing. What if this had been 4 years, right? So this would have become 4th root. It would have become even more difficult, and maybe in some cases impossible to solve without the use of a calculator or a logbook, right? So remember, this is a universal problem for everyone, right? But as far as concept is concerned, we should have no issue. This is where I'll get my answer, and then I'll work out the value of r, right? So how do we deal with such a question, especially in a competitive test scenario or in a limited time scenario, right? So obviously maybe the person who's setting the exam also is not looking for your ability to find the 4th root. He is looking at your ability to understand the concept, right? So let's look at this question again and apply basic percentage knowledge, right? So something has gone from 100,000 to 1,10,250. Can I find the overall growth rate, right? Or can I find the overall percentage change, the most basic of percentage questions, right? And even for that, the faster way of one is you can subtract. Answer is 10,250 divided by 1 lakh, right? 1,025 about 10,000. Basically 1,000 over 10,000. So overall in 2 years there is a growth of 10 point some percent, right? You could have directly done 1,10,250 by 100,000. You would have got a multiplying factor, and you would have got the same thing, that overall there is approximately a 10 point some percent growth, right? So in 2 years there is a 10% growth. So in each year how much is going to happen? So it's going to be approximately 5%, right? So now if I have this knowledge and if I have a test based on options, I can go the option nearest to 5, right? I can go for the option which is nearest to 5. So it's not a foolproof technique, because somebody might put an option 4.5.1, 5.125, 5.235. Again, life would become difficult and we would have to think in more detail. But this is just an introduction, that looking at the overall percentage change, or also remembering that in 2 years it is nothing but a case of A plus B plus AB upon 100, successive percentage change. And in this case A and B are the same because the same rate. So 2A plus AB upon 100 is equal to 10 point something, right? 10.02 or whatever, don't worry about it. So A square. So you can again use this equation to work out, because you know overall in 2 years there was 2% and 10%, and you know compound interest is the same as successive percentage growth. So A plus B plus AB upon 100, and B is the same as A because the rate is fixed, right? So point being that finding the square root might be difficult, but maybe using a logical observation and thinking, okay, 5 plus 5 is 10, plus 5 into 5 by 100, right? So it looks like 10.25 which is there. So maybe 5% is my answer. I'm not recommending this process in questions where a definite answer is required, but definitely in tests where there are options there, maybe all the options will be very far away from 5. Maybe one option would be 7, 9, 11, 13. So life would be very easy without even using the formula, right? But remember, finding the square root is a problem. Chances are we'll not master this process. Square root we might still learn, but the fifth root will not be able to learn. So I'll have to do some kind of thinking there, right? While understanding the basics of successive percentage change. Okay, now we're just trying out questions and trying out connections of various concepts. The question is, there is some principle, doesn't even matter what the principle is, though the question might have some specific value. The rate is 10% and the period amount is 3 years. The question is, amount is what percent more than the principal? That means after 3 years you would get some amount, and that amount is what percent more than the principal. So if you're looking at the percentage relationship between A and P rather than the actual amount, right? So obviously one is I can understand that amount is equal to P into 1 plus R by 100 raised to 3, right? So amount is equal to, and R is 10, so P into 110 by 100 raised to 3. Now amount is equal to P into 11 cube by 10 cube. So 11 cube still might be easy, right? But what if the number was 12% here or 12.5%? So the calculation would become difficult, right? And if I know my percentage, I can, let's say 11, had this been 11 square, like let's say 2 years, right? And I get A is equal to P into 121 by 100. What does this mean? What does this expression mean in this language? What percent more than P? A is 21 by 100 of P more than P. That means A is 21% more than P, right? So by squaring or by understanding successive multiplying factors also you would have got the same thing. Amount is P into 11 by 10 after 1 year, and amount is another 11 by 10 after 2 years, and after 3 years it would be another 11 by 10. So we're trying to connect the formula with the multiplying factor method also, right? But in any case, let's say you got this 21%, which is fine for 2 years, right? But for 3 years, the calculation would have become difficult. So how can we make our life easy? By using the successive percentage change formula, right? But my successive percentage change formula works only for 2 years. It works for 2 successive growths, right? I know A plus B is equal to the overall percentage change, let's call it X, right? So A and B, A plus B plus AB upon 100, A and B being the growth rates for each year. Since the growth rate is the same, this would be 10 plus 10 plus 10 into 10 by 100. 10 plus 10, 20, 100 by 100 gives you 21%, which we just worked out, right? So this might have made my life easy for the 2-year case. But what do I do for the 3-year case? I know after 2 years this is 21%. So it is now 21% plus 10% plus 21 into 10 by 100. So this calculation might be easier than the cubing calculation, especially when it comes to 2 or 3 years, right? So instead of finding the cube, I'm going for A plus B plus AB upon 100. And remember, even that formula I have to use twice. Once for 2 years, from that I will get a result, and that I will combine with the 3rd year and I will get my overall answer, right? So again, I'm saying in 10% it was still easy. Had it been 15%, right? So for the first 2 years, the overall growth would be 15 plus 15 plus 15 into 15 by 100, which is 32.25. And for the 3rd year, 32.25 plus 15 plus 32.25 into 15 by 100. Again, you might think that this is a heavy calculation, but majority of the things you've already figured out. 32 plus 15, 47 plus something is going to come out of here. So you've got the range, right? So point being that nothing else, revise the successive percentage change formula and understand that how compound interest is a case of successive percentage change or a series of multiplying factors, right? So I hope this made sense. In case you don't know what I'm talking about here, please go through the percentage sessions and cover the part on successive percentage change formula, right? So very many ways of looking at problems. If your fundamentals are clear, if you know what percentage really means, then you can apply it anywhere. Okay. This question says the ratio of CI in the 7th and the 8th year is 10 is to 11, right? That means you had some principal and some rate. After 7 years, whatever was the interest generated in the 7th year, the ratio of that to the 8th year interest is 10 is to 11, right? So again, this will become very complicated because even my formula only works for amount, and then amount minus principal will give me the CI. So a lot of steps, right? But if I understand the most fundamental concept of compound interest, that means for the 8th year, the principal would have been the amount for the 7th year, right? And I know that in 2 successive years, the amount generated in compound interest should have been the same. But why is there this extra 1? Where is this coming from? I know this 1 is coming from this particular interest, right? The change is interest on the interest in the previous year, right? So this 1 is coming from 10, and 1 is what of 10? It is 10%, right? So, or you could have said the interest has grown by 10%, something has gone from 10 to 11, the multiplying factor is 11 by 10, there is a growth of 10%. So therefore, the rate is 10%. So not only for the compound interest, I could have also said the amount in the 3rd year is 25,000, right? And amount in the 4th year is 30,000. So what is the rate? What is the rate of interest? Again, I will not use the formula. I will remember that the amount for the 3rd year is the principal, and on a principal of 25,000, in 1 year you're going from 25,000 to 30,000. That means 5,000 is the extra interest. 5,000 on a base of 20,000, 5 by 25 gives you 1 by 5, which is 20%. So you could have also done this by using multiplying factors. 30 by 25, which means 6 by 5. 6 by 5 means an increase of 1 by 5, means an increase of 20%. That means the rate is 20%, right? So remember, if you have 2 consecutive years data, you don't need to use the formula at all. Just find out the percentage change between the years and you will get your growth rate, or you will get your rate of interest, right? So again, knowing the fundamentals, understanding what is the story behind the formula and everything can make our life easy in a lot of situations. Even though cubing will remain a problem, finding the cube root or the 4th root will remain a problem, right? Which we'll have to figure out by using different methods of calculation, etc., which we may work on. But as of now, understanding these kind of basics and insights. 2 points to this question. One, that when we're talking about growth rate of population, we have to understand we're talking about compound interest, right? In any kind of growth rate, let's say we're talking about any kind of population growth rate, we're talking about bacteria or fungi or anything. So the concept that is used is the concept of compound interest, right? Why? When 2 people become 4, 4 people will become 8, right? Using hamare do formula, right? So that is one idea, and the second would be the idea of using multiplying factor. So I know whatever was the population in 2003 was multiplied by what? 12.5%. 12.5% means 1 by 8. An increase of 1 by 8 means a multiplying factor of 9 by 8, right? That means if I take the population of 2003 and multiply it by 9 by 8, I'll get the population of 2004. So this expression is the population of 2004. Again, if I multiply this by 9 by 8, what do I get? I get the population of 2005, because this 2004 population has grown by 12.5%. This is 9 by 8. This expression represents 2005's population. Increase it by another 9 by 8. So you finally get to the population of 2006. 2003 multiplied by 9 by 8 gives me 2004, multiplied by another 9 by 8 gives me 2005, and multiplied by another 9 by 8 gives me 2006, and that is equal to 729,000, right? This should have been fairly easy. This is 9 cube, right? So in this particular case, and this gets cancelled and we get 8 cube, right? So the population for this, the 2003 population for this country was 5,12,000 in 2003, right? So again, if you want to look at the question, here in this case, the amount was given because after 2006, right? Or in 2006, and we started with the population in 2003. So this was the principal and this was the amount. So you could have also used the formula, but maybe using the multiplying factors would have made life easy in this case, right? Plus we get to revise our most basic percentage concept, growth, right? Okay. Another question where we'll see that instead of the formula, knowing the basic concept will help us a lot more in getting to the answer. So the question is, there was some amount deposited and the amount became 3 times the original amount after 5 years, right? That means you have the amount, you have the principal, you have the time, the rate is missing so far. And the question was, in how many years will it become 9 times the principal, right? So let me try out the formula just to see the problem there. So I know amount is equal to P into 1 plus R by 100 raised to 5, right? Because we're talking about 5 years. And this amount, instead of amount, I can write 3P. So I know quickly PP will get cancelled and I have to find the fifth root of 3 and then I get the value of R, right? That is the way I would normally go if I were not thinking at all, right? And then I have to figure out in how many years will it become 9P. So I will say amount is equal to 9P is equal to P into 1 plus whatever R value that I would have got from here raised to X, right? And I would have figured out the value of X, which would have told me how many years does it take to figure out the value of 9P, right? So obviously I can see the fifth root of 3 is going to be very, very problematic for me, right? So what can we do about this question without using this formula, right? So let's go for the most basic idea of compound interest. We started with P and after 5 years we became 3P, right? After 5 years, we know what is the most fundamental idea of compound interest, that the new amount, is the new principal. That means now this is P. And I know what happens in this case. P in 5 years becomes 3 times, right? So this P, call it P dash if you like, in 5 years, what will happen? This will become 3P dash, right? And what is P dash? P dash I know is 3P. So if I put 3P here, I get 9P. That's what I wanted, right? So P went from P to 3P in 5 years and from 3P to 9P in the next 5 years because this became the principal, right? So this particular question with this setup was very, very easy. And this is a case of geometric progression, right? You're getting, so P was multiplied by 3 in 5 years. In the next 5 years also, it will be multiplied by 3, luckily ending up at 9P, straight away getting your answer. You can go back to the simple interest video and you can compare this progression with the simple interest progression where it was a arithmetic progression. Every year the same thing was getting added. So for example, had the same question been in SI, you would have said, okay, P to 3P, that means 2P is getting added in 5 years. And the next 5 years again 2P will be added, you get 5P and then you will get 7P and then you will get 9P. So 5 years, 5 years, 5 years, 5 years, it would have taken 20 years. Here it is only taking 10 years, right? So remember, basic understanding, the principal, the amount is the new principal. In 5 years, this principal became 3 times. So obviously this principal also become 3 times. The question could also have been 27 times, 81 times, etc. And you can jump the steps, right? 9. In the next 5 years, this would become 27 times, right? So that's the idea. Know the formula, understand it very, very well, but know what is the meaning of the formula and what is the most fundamental concept involved. In compound interest, the most fundamental concept is successive percentage change and the idea that the principal itself is changing. Okay, talking about insights, let's do a little comparison between CI and SI, right? Let's compare 2 examples. Let's take 100 as a principal and the rate as 10% for both the cases, right? And see what happens to the interest. So in the first year for SI, rate of 10%, 10% of 100 would give me 10. And for CI, the principal is 100, rate of 10% would give me 10. That means for the first year, or if there is only one time cycle involved, there is no difference between CI and SI. And there is no difference between the interest, right? Okay. What about the second year? For SI, I know the rate is same and the principal is same, therefore the interest would also be the same. I could have directly done this, or again calculate 10% of 100 and you get 10, right? But what about compound interest? You had 100 and interest was 10. After 1 year, it would become 110. That means you have to find 10% of this, right? So what do I get? 10% of 100 I know is 10, which is the same as this. And 10% of 10 gives me 1, right? So 10 plus 1. So I would have directly written 11 also, right? So again, if I compare, what is the difference in the second year in the interest? This is 10 and this is 11. But what is the change? This 1 is the change. And where did this 1 come from? It came from 10% of 10. And what is this 10? It is interest on the principal. And what is this 10%? It is interest on the principal. So can I say the difference between SI and CI after 2 years, the difference between the simple interest generated and the compound interest generated after 2 years, which is 1 in this case, is nothing but interest on the principal, or this 1 is equal to 10% of P, right? And in the generalized form you will say the difference or delta is equal to R% of P, right? So again, if I know this, if I understand the change in interest or in amount, okay, for example, the amount would be 110 plus 10, 120 point. The amount would be 121 and the amount would be 120. So the difference between the amounts also after 2 years is R% of P. Interest on the principal, right? So knowing this very basic insight can also give me some answers fairly quickly, right? Or maybe some questions can be designed on the back of this concept. Okay. So let's apply the concept a little bit. So there's a man who invests 50,000 rupees in 2 programs, one at a simple interest rate of 8% and the other at a compound interest rate of 8%, right? So he's doing it 50,000 and principal for SI and principal for CI, both is 50,000, right? So the principal is the same, the rate is the same, the period is the same. One is SI and the other is CI. And the question is, what is the difference in the interest or the amount after 2 years, right? So one would be you find out the amount using the SI formula and you find out the amount using the CI formula. But since the question is about the difference after 2 years, you straight away can go for R%, or let me make it even easier, R by 100 into R by 100 into P will give you the change. This is what we learned from the previous example, right? So I know this P is 50,000, R is 8. So you get 8 by 100 into 8 by 100 into 50,000 is your answer, right? So this 100 takes out this 100 takes out this. 5 into 8 into 8 is your answer. 8 5s are 40 and 40 into 8, 320. So straight away, if I understand the very most basic idea that what is the change after 2 years, I could have used that formula to get to the answer faster, right? And other questions can also be made on this. Okay, let's try this question. It says the ratio of CI upon SI after 2 years is 16 by 15, right? That is the only information given to us. So we have just done the idea that what is the fundamental difference between CI and SI, and especially after 2 years, what is the change, what is the difference, right? So we did that idea. But let's try this. Let's form the same table. So this is year 1, this is year 2, this is CI and this is SI, right? I know how to deal with ratios. Just throw an X so this can become usable for you. So the total CI after 2 years is 16x and the total SI after 2 years is 15x, right? Now use the concept that SI is constant across the years, right? That means A plus A gives you 15x, or for the first year it is 7.5x, and for the second year also it is 7.5x. What is the idea that I am using? That the simple interest is the same each year. So 2A is equal to 15x, A is equal to 7.5x, right? Now, work backward. I know SI and CI are the same in the first year. So this is 7.5, right? Right? Because there is no difference between SI and CI in one time period, right? And if this is 7.5, that means the next year is going to be 8.5 to make it 16, 8.5x, right? So then I can figure out what is the rate of interest. Why? Because from 7.5 I've gone to 8.5, that means I've gone 7.5 plus 1. And where did this 1 come from? This 1 came from the rate of interest being applied on 7.5x, right? So my rate is 1 upon 7.5 or 2 upon 15. 1 upon 15 is 6.66. So 2 into 6.66 would be 13 point something, right? So that is one way of solving this problem, right? So again, the idea being that very basic ideas can lead you to the answer instead of using the formula. And what are the ideas that we use? SI is the same across years, and SI and CI are the same. The change in the interest is nothing but interest on the interest, so I use that also, right? Another formula worth noticing, though you don't really need it, and you should work it out by yourself that how did we come to this, is that the ratio of CI and SI after 2 years is 2 plus R by 100 divided by 2. I'm leaving the deduction of this formula to you. And how will you work this out? You know, first year CI is R percent of P, and second year CI is R percent of P plus R percent of R percent of P, and similarly for SI, and then a lot of things will get cancelled out. For now, I'm leaving that deduction to you, but this formula will work. So if you try the previous question where it was given that SI, if we try out the previous question where it was given that CI upon SI is equal to 16 by 15. If I just equate it to this formula, also I will get the answer, right? So if you know this, then this would have been even shorter, right? But I'm not in favor of remembering too many formulas. I'm in favor of remembering the core ideas of how to work percentages and understanding the core relationship between things, right? But if you want to, why not? Also spend 2 minutes and work out how did we come to this. This would become easier, and find out the answer for this and compare it to the previous answer. See whether it works or not, right? Okay, let's try out the exercise now. Question number 16. The CI earned in 7th year is 500. What would it be in 8th year? And the rate of interest is 15%. I know in 8th year it would definitely be 500, because this 500 has come from interest on the principal. Plus it would be 15% of 500, right? Why? Because the interest on interest will also be added. So that is 75. So your answer would be 575, right? So this was question number 16 in the sheet. Question number 17. The compound interest earned in 3rd year is 450, and in 4th year it is 500. What is the rate of interest? Should be very easy. It is 50 upon 450, right? Where does this extra 50 come from? This extra 50 came from the interest on 450. So 50 upon 450, 1 by 9, 11.11% is your answer, right? This one says the interest after 8 years was 484, and the rate of interest is 10%, right? And the question is, what would be in 6th year, right? So let's call it I, interest is I. I know the rate is 10%, so the interest for the 7th year would be 10% more than this. Use the multiplying factor I into 11 by 10. And from 7th year to 8th year, again there will be a multiplying factor of 11 by 10, because that would grow by 10%. And this will give you 484. So I is equal to 484. 4 into 10 into 10 by 11 by 11. These multiplying factors were inversed and shifted to that side, right? 11 44s are 11 fours are 44 and 4s are 44 and 11 fours are 44. 4 into 10 into 10 gives you 400. So the interest in the sixth year would be 400 rupees, right? Question number 19 says if the rate is 12.5%, right? And remember 12.5% is 1 by 8 and a multiplying factor of 9 by 8. So it says the rate is 12.5%, find the ratio of compound interest in the 24th year and the 25th year. In 24th year, in the 25th year. Again we are talking about consecutive years. So whatever was the interest in the 24th year, it would be multiplied by 9 by 8. And how did I come to this quickly? Again, we are assuming that you have thoroughly mastered the basics of percentages. So this is all very basic steps for you. So I into 9 by 8 gives you I dash, right? So the ratio of 24th to the 25th year, that is I upon I dash, will be 8 by 9. So the answer is 8 by 9. In fact, if you notice and understand the basic concept, you know from 25th to the 26th year also it would be 8 by 9, right? Because there's a growth rate of 12.5%, which means a multiplying factor of 9 by 8. So that we keep repeating. So for any 2 consecutive years, for this rate, the ratio of CI for 2 consecutive years is always going to be 8 by 9 for this particular rate, right? So I hope you notice all of these things, right? Question number 20, it says the ratio in the nth and the n plus 1 year is 15 is to 16. This should have been very easy, right? Something has gone from 15 to 16. There is a change of 1 by 15 and 1 by 15 means 6.66%. So again, the moment you see consecutive years, you just have to find the ratio or find the change and using the previous year as the base and you'll have your answer, right? If I were using the ratio of new by old, I would say 16 by 15 and then I would understand in my head that 16 by 15 means a change of 1 by 15, which means 6.66%, right? So again, basics of percentages will definitely help in your speed in compound interest problems. Okay. Question number 22, the difference between the compound interest and simple interest on amount of rupees 8,000 in 2 years is 405. So use the 2 years formula. 405 is equal to r square, or if you want to do it fully, r by 100 of p and interest on that, r by 100 of p, right? And the p in this case is 18,000. So put 18,000, right? So solve this, and this 18 by 10 is 9 by 5, this becomes 5 by 9 in this side. Work it out. 9 fours are 36 and 9 fives are 45, right? And 45 into 5. So 45 into 5 would be, what am I doing? 45 into 5 would be 225, and this is equal to r square. So r is equal to square root of 225. This should have been easy. 225 is 15 square. The rate of interest in this particular question was 15%. So I hope you see in these questions that once you understand the basics, you will not even need to use the formula in a lot of cases, right? Or at least you learn how to not use the formula and think a little bit, and then it becomes a simple case of percentage increase, which if you think about it, you've learned more in percentages. In percentages, you've learned increase as well as decrease, and you can deal with changing rates. Here is actually easier, the rate is fixed already. So the only problems might be sometimes cubing of numbers or finding the root of numbers, but that is unavoidable. And again, I'm thinking that in any such exam, calculation is not the agenda. Observation, using the core concept to get to some insight which can then help you solve the problem is more the attention, right? So that's it for this compound interest session. Download the sheet from the description box, go through the theory, revise all the questions, and I think you should be okay with compound interest. This will also play out in data interpretation, calculation techniques, etc. Meanwhile, if you are struggling with the cubing, maybe find something on Vedic maths and learn techniques on cubing, which will definitely help things in simple interest, compound interest problems. Okay.